We have seen how we can solve a system of linear equations when there is only one variable or one equation. We now look at the more general case. The basic idea is to reduce a system until it gets down to the special cases. We'll now see how that can be done. Consider this system of linear equations defined over the rational numbers. If you look at the first equation, it is equivalent to the following. So I'm going to add x2 to both sides, and that will give us 2x1 equals x2. And then multiplying both sides by 1/2, I get x1 equals 1/2 x2. What this is telling us is that once you know the value for x2, x1 is simply 1/2 x2. And so we can replace x1 with 1/2 x2. And we're going to do that for the second and third equations. So replacing x1 with 1/2 x2 in the second equation gives us minus 1/2 x2 plus x2 minus 2x3 equals 4. And replacing x1 with 1/2 x2 in the third equation gives us 3/2 x2 minus 2x2 plus x3 equals minus 2. And simplifying gives us the following. 1/2 x2 minus 2x3 equals x4, and minus 1/2 x2 plus x3 equals minus 2. Now, if you look at this system, there is one fewer variable and one fewer equation than the original system. And we can do something similar using the first equation here. So I'm going to use this to write x2 in terms of x3, and that will give us the following. So first of all, adding 2x3 to both sides, I get 1/2 x2 equals 4 plus 2x3. And then multiplying both sides by 2, I get x2 equals 8 plus 4x3. So we can now replace this x2 with the right hand side 8 plus 4x3. And that will give us minus 1/2 times 8 plus 4x3 plus x3 equals minus 2. And let's simplify this. So this will be minus 4 minus 2x3 plus x3 equals minus 2. And so minus x3 is going to be 2. So x3 is going to be minus 2. And so x2 will have to be 8 plus 4 times minus 2, and that's just 8 minus 8, which is 0. And if x2 is 0, then x1 has to be equal to 0 as well. So the system has a unique solution given by x1, x2, x3 equals 0, 0, minus 2. So this example illustrates what is known as the method of substitution. And in a nutshell, the essence of the method can be summarized as follows. So unless your system has one variable or one equation, which we know how to solve, you can do the following repeatedly. You pick one of the equations and then rewrite it to an equivalent one so that one of the variables, let's say xi, is expressed in terms of the rest. And then what you do is you form a new system by replacing xi in each of the remaining equations with the expression for xi. Then you'll end up with a system with at least one fewer equation and one fewer variable. So if you do this repeatedly, eventually you'll get down to a system where you can easily find the solutions.